Welcome to the next video of Understanding the Chemical Reaction series. Today we are going to be talking about how activation energy becomes a barrier to overcome during a chemical reaction. So in the last video we started with an analogy about activation energy where a man pushes a stone from a mountain. The energy that the man requires to push the stone down the mountain is called the activation energy, while the chunks that are forming from the stone after being fallen down from the mountain is the products forming in this example. Now, same happens with a chemical reaction. Activation energy in a chemical reaction is the minimum energy that is required to start a reaction. So today we will study in depth about what an activation energy actually is and how it is involved in a chemical reaction. Alright, so let's delve deep into activation energy and how it acts as a barrier in chemical reaction. Let's start off by looking at this energy profile diagram. Here, the y-axis represents energy and the x-axis represents the progress of the reaction from reactants to products. So as you can see on the left side, we start with our reactants at a certain energy level. For a reaction to occur and transform these reactants into products, the particles involved needs to reach a specific energy threshold. This is known as the activation energy, shown here as the peak in the curve. The activation energy, or EA, is the minimum energy required for the reaction to proceed. Without enough energy to reach this point, the reactant particles simply cannot react. Think of it as a hill or barrier that the particles have to climb over to reach the other side where the products form. At the very top of the hill, we reach something called the transition stage. This is where old bonds in the reactants are breaking and new bonds are starting to form. It's an unstable, high energy state where the molecules are in transition between reactants and products. Once the particles reach this transition state, they have enough energy to complete the reaction, moving down the curve to form the products on the right side of the diagram. Notice that the products are at a lower energy level than the transition stage, showing that energy is released as the reaction completes. So, activation energy is crucial because it creates a sort of barrier. Only particles with enough energy to climb over this barrier can successfully react and form products. So, now let's look at an example using a reaction between hydrogen and oxygen to form water. In this reaction, hydrogen and oxygen molecules are our reactants and water is the product. The reactants must absorb enough energy to reach the activation energy shown here, where the bonds in hydrogen and oxygen start to break, allowing new bonds to form in water. Without sufficient energy, this reaction wouldn't happen at all. Now remember that activation energies vary depending on the reaction. So it varies from reaction to reaction. Different reactions have different kind of activation energies. Some are higher and some are lower. Now let's explore how catalysts play a key role in chemical reactions, particularly overcoming the energy barrier we call activation energy. In a typical reaction, reactants need enough energy to reach the transition state, the point where old bonds are breaking and new bonds are forming. This peak on our graph shows the activation energy, which is essentially the hurdle reactants must overcome to form products. Now here's where catalysts come in. A catalyst provides an alternative reaction pathway, one that requires less activation energy. You can think of it as a shortcut. By lowering the peak or the amount of energy requiring to reach the transition state, catalysts make it happen for the reaction to happen without using as much energy. The results faster reactions that require less energy input, allowing reactions to proceed more readily.